Hi, we are from Group 6, and this will be our video presentation for the RAM study of the natural gas processing plant. A little bit of introduction regarding RAM analysis, which is usually used to optimize equipment's performance. Other than that, the RAM is done by utilizing the reliability block diagram of the natural gas processing plant to find the availability and reliability. Why it is important to optimize the equipment? This is to lower the production loss, reduce the maintenance cost, and also lessen the downtime, which will be very beneficial to the company. Moving on to the objective. The first objective is to evaluate the average availability and reliability of natural gas processing plant for the period of 3 years. Second objective is to identify the critical equipment that contributes to the availability figures. Third objective is to propose action plans that need to be done in order to allow the plant to achieve 99% of availability. For this project, a few assumptions have to be made. First is the equipment under the same category share the same failures data. Second is the final failure time of components in data assumed as the end of the observation period. Third is the system is assumed to be non-homogeneous fusion process and the power law is applied for the calculation. And last assumption is the reliability and availability of the system is evaluated in the period of 3 years, which was assumed to be 195 days.
Moving on to the calculation theory, expected reliability and mean time between failure MTBF can be calculated by using power law model as below. The expected reliability between periods T1 and T2 can be calculated as the MTBF mean time between failure of T1 and T2 can be calculated as inherent AI or availability can be calculated as the system can be made up of two types, which is series system and parallel system. This is the series figure of a series system. Based on the figure above, the reliability can be obtained by multiplying R1 times R2 times R3, while the availability can be calculated as A1 times A2 times A3. Moving on to the parallel system, this is the figure example of a parallel system. The reliability of a parallel system is equal to 1 minus the product of 1 minus R1 times 1 minus R2. On the other hand, the availability of a parallel system is equal to 1 minus the product of 1 minus A1 times 1 minus A2.
For the calculations part, firstly we need to calculate the components' reliability and availability. The given data is mean time to repair and the failure times, which is to be calculated into mean time between failure, reliability and availability for each component. The period assumed is 3 years, which is 195 days. Firstly, we need to calculate the MTBF and the reliability for each component using the lambda and beta given. Next, we can calculate the availability, which is the average between mean time between failure over total of mean time between failure plus mean time to repair. Since there are 16 components altogether, we have used Microsoft Excel to ease our calculations since they are very repetitive. Once you have calculated the components' reliability and availability, now we can move on to the subsystems calculation. There are two types of connections, which is the series connection and the parallel connection. As can be seen in the slide, medium pressure separation and compression unit as well as high pressure separation unit are both in series connection. We can also see that in series connection, as the number of components increases, the number of reliability decreases. That's why the high pressure separation unit is having much higher reliability compared to medium pressure separation and compression unit. Moving on to the third and fourth subsystem, which is the feed gas compression unit and the acid gas removal unit. For these two subsystems, they are both in series connection as well. That's why feed gas compression unit is having much lower reliability than acid gas removal unit, as it has more number of components. The fifth subsystem is the amine regeneration and sulfur recovery system. This is a combination of two connections, which is the series connection and parallel connection. The calculation part is a bit tricky. As we can see here, firstly we have to calculate the series connection first, the 5 series connection first. Then we are going to multiply it with the parallel connection, which is the reflux pump and the lean amine pumps. Same goes to subsystem availability.
The results show the reliability and availability for the dehydration unit, which consists of sweet gas cooler, sweet gas KO drum, feed gas spray chiller, feed gas separator, and inlet gas filter. While the other one shows the reliability and availability for the natural gas liquids recovery unit, which consists of feed gas filter, feed gas exchanger, feed gas separator, feed gas chiller, gas separator, and demethanizer. By combining all the subsystems reliability, we can get the overall reliability for the plant, which is 0.000001, which is very small. And by combining all the subsystems availability, we can get the overall availability for the plant, which is 0.982087. There are a few critical equipment or bad actors that contributed to the availability value. Firstly, the two lean amine pump that having the 2 out of 2 configurations which are responsible for the largest loss to the plant availability. The other bad actors, which are the components that have low availability, are suction drum, absorber, chiller, and demethanizer. All of these equipments are arranged in series configuration, thus having bigger impact to the overall plant availability.
In order to improve the plant availability, the mean time between failure need to be increased and the mean time to repair need to be reduced. The mean time between failure can be increased by improving technician skill and knowledge on handling machine, using better quality components, conducting consistent cleaning and inspection. On the other hand, the mean time to repair can be reduced by reducing the response time of maintenance team to the failure, reducing the time travel for the maintenance worker to the site location, and lastly, introducing proper standard operating procedure. Critical equipment such as suction drum, absorber, chiller, pump, and demethanizer are chosen to further improve their availability. The new mean time between failure and the mean time to repair are obtained. In conclusion, the reliability block diagram of the plant is constructed. Reliability and availability of the plant is evaluated by using power law. Lastly, natural gas processing plant is able to achieve 99% availability after the improvement is made.